Lesson: Techniques to Identify and Measure Bias. Bias in artificial intelligence is a multifaceted issue that affects the fairness, transparency, and accountability of AI systems. Understanding and addressing bias is crucial for AI compliance and ethics auditors, who play a pivotal role in ensuring that AI technologies are fair, ethical, and in compliance with regulatory and societal standards. This lesson delves into actionable techniques for identifying and measuring bias in AI systems, providing a comprehensive guide for professionals in the field. Identifying bias in AI begins with understanding the sources of bias. Bias can originate from the data used to train models, the algorithms themselves, or even the way results are interpreted. Data bias occurs when the training data is not representative of the population it intends to serve, leading to skewed outcomes. For instance, a facial recognition system trained predominantly on Caucasian faces may not perform well on individuals of other ethnicities, leading to higher error rates for those groups. Algorithmic bias can arise from the design or implementation of the algorithms, which may inadvertently favor certain groups over others. Interpretational bias occurs when the outputs of AI systems are misinterpreted or misused, potentially reinforcing existing stereotypes or inequalities. To effectively identify bias, AI auditors must utilize a combination of qualitative and quantitative methods. Qualitative analysis involves examining the data collection and processing methods, understanding the context in which the AI system is deployed, and reviewing the decision-making processes involved in algorithm development. This approach requires a deep dive into the life cycle of AI systems, from data acquisition to model deployment, to uncover potential sources of bias. Quantitative methods, on the other hand, involve statistical tools and metrics designed to detect bias in AI outputs. One commonly used metric is the disparate impact ratio, which measures the effect of an AI decision on different groups. A ratio significantly different from one indicates potential bias, suggesting the need for further investigation. Another tool is the fairness through awareness approach, which involves creating models that are sensitive to demographic information and adjust their predictions to ensure equitable outcomes across all groups. Beyond identifying bias, measuring bias is crucial for quantifying its extent and understanding its implications. Tools such as the bias variance decomposition provide insights into the trade-offs between bias and variance in machine learning models, helping auditors assess whether a model's performance is due to bias or inherent noise in the data. The use of confusion matrices and classification metrics like precision, recall, and F1 score can also provide a detailed understanding of model performance across different groups, highlighting any disparities that may exist. Practical tools and frameworks play a vital role in identifying and measuring bias. The AI Fairness 360 Toolkit, developed by IBM, offers a comprehensive suite of algorithms to detect and mitigate bias in AI models. It includes metrics to assess bias in datasets and models, as well as algorithms to mitigate identified biases, making it an invaluable resource for AI auditors. The fairness indicators from TensorFlow are another powerful tool, providing a scalable approach to evaluate and visualize fairness metrics, enabling auditors to gain insights into model performance across different slices of data. A case study that illustrates the effectiveness of these tools is the use of the AI Fairness 360 Toolkit in a recruitment context. A company discovered that their AI-driven recruitment tool was favoring male candidates over female candidates. By applying fairness metrics from the toolkit, the company identified that the training data contained historical biases that led to skewed outcomes. By employing bias mitigation algorithms, they were able to adjust the model to ensure fairer hiring practices, demonstrating the toolkit's practical application in real-world scenarios. Frameworks such as the Fairness, Accountability, and Transparency in Machine Learning framework provide structured guidelines for evaluating bias and fairness in AI systems. FATML emphasizes the importance of transparency in AI processes, advocating for clear documentation of data sources, model assumptions, and decision-making processes. This framework encourages auditors to adopt a holistic view of AI systems, considering not just the technical aspects, but also the ethical and societal implications of AI deployment. To effectively implement these tools and frameworks, AI auditors should follow a step-by-step approach. The first step is to conduct a thorough data audit, examining the representativeness and quality of the training data. This involves identifying any underrepresented groups and assessing the potential impact of data imbalances on model outcomes. Next, auditors should evaluate the algorithms themselves, reviewing their design and implementation for any inherent biases. This includes testing models on diverse datasets to ensure they perform equitably across different demographic groups. Once potential biases are identified, auditors must measure the extent of these biases using appropriate metrics. This involves calculating disparate impact ratios, analyzing confusion matrices, and employing fairness metrics to quantify bias. Based on these measurements, auditors can then apply bias mitigation strategies, such as resampling the training data, adjusting model parameters, or implementing fairness-aware algorithms. Finally, AI auditors should document their findings and the steps taken to address bias. This documentation should include detailed reports on the data audit, algorithm evaluation, bias measurement, and mitigation strategies. Transparency in this process is crucial as it builds trust with stakeholders and ensures accountability in AI systems. The importance of addressing bias in AI cannot be overstated. Biased AI systems can perpetuate and even exacerbate existing inequalities, leading to unfair outcomes that impact individuals and society at large. By employing the techniques outlined in this lesson, AI auditors can play a crucial role in promoting fairness and ethics in AI, ensuring that these technologies serve the greater good. In conclusion, identifying and measuring bias in AI systems requires a comprehensive understanding of the sources of bias, the application of both qualitative and quantitative methods, and the use of practical tools and frameworks. By following a structured approach, AI auditors can effectively detect and mitigate bias, promoting fair and ethical AI practices. The techniques and tools discussed in this lesson provide a robust foundation for professionals seeking to enhance their proficiency in auditing fairness and bias in AI systems, contributing to the development of more equitable and responsible AI technologies.